left Ukiah at noon. 2 hours later, a westbound bus left the same station. If the buses traveled at the same rate and were 500 kilometers apart at 6 p.m., find the rate of each bus. All right, so our picture, you guys, we're heading eastbound, and then we're heading westbound. So we're starting at the same point, and our distances point out, right? And we're going to label these with our eastbound, distance, eastbound, distance, westbound. All right, so these are going to add to be how many miles, you guys? 500, thanks, kilometers. So distance of the eastbound train plus distance of the westbound train equals 500 because it says they were 500 kilometers per apart, so we're going to find the rate of each bus. All right, we replace every single time our distances with rate times time. So rate of the east times time of the east plus rate of the west times time of the west is 500. All right, so it says that the eastbound train left at noon, and we're ending this at 6 p.m. So raise your hand if you can tell me how many hours, what we're going to plug in for time of the eastbound train. Bethany? Yes, that would be 6 hours. From noon to 6 p.m. is 6 hours, right? And then it says 2 hours later, the westbound train left the station. So raise your hand if you know what we should plug in for the time of the westbound train. Isaac? Okay, 4 hours. It's 2 hours less. Good. All right, and then there's one more side equation we can write down. It says the buses traveled at the same rate. All right, so that means that the rate of the eastbound is equal to the rate of the westbound. So you can plug in whichever one you want. So I'll make them both RWs. And RW equals 500. Now this becomes a pretty easy problem. So we have a 6 RW plus a 4 RW equals a 10 RW. Then we're going to divide both sides by 10. So the rate of the westbound, I've been saying train, bus, is 50 kilometers per hour. All right. And it says to find the rate of each bus. So the other one is the exact same, right? It says they traveled at the same rate, so we get 50 for both. All right, last one. Ed and Alice walked to the dock at 5 miles per hour, jumped into the boat, and motored to Destin at 15 miles per hour. If the total distance was 20 miles and the trip took 2 hours in all, how far did they go by boat? All right, so a little punctuation there. All right, so we're traveling partially jogging or walking or whatever, and then we're getting in a boat. So that means there's a portion of the trip that we're walking, and then we're going further by motoring. All right, so we're going to call this one distance walking, and then we're adding on to our total distance here, and this is going to be distance in the boat. I guess we could use M for motoring or B for boat. I don't care. All right. So these add to a total of, the total distance was 20 miles. So our equation is going to be addition. And we're going to replace them both with rate times time. So RWTW plus RMTM equals 20. So Ed and Alice walked to the dock at 5 miles per hour. So somebody who hasn't participated yet, tell me where that goes. Ella? Good. So our rate walking is 5 miles per hour. Then we jumped into the boat and motored to Destin at 15 miles per hour. Somebody else tell me where the 15 goes. Evie? RM. Good. Okay. So Total distance is 20 miles. The trip took 2 hours in all. We need to write an equation off to the side for the trip took 2 hours in all. Somebody else tell me what that equation would be. Micaiah? Yep. Total time is 2 hours. Now we can solve for either one of those. So I'm probably just going to subtract TM from both sides. So I have TW equals 2 minus TM. So I'm going to have to squeeze in this equation right here for my TW. So TW is here. I'm going to try to squeeze that in. 2 minus TM plus. All right, and then TM over here equals 20. Okay. Now we need to distribute the 5. So when we distribute the 5, we get 10 minus 5 TM. Then I have a plus 15 times TM, so plus 15 TM equals 20. So I'm going to subtract 10 from both sides, and I'm also going to add like terms right here. So negative 5 plus 15 gives me 10 TM. 20 minus 10 gives me 10. Divide both sides by 10, and we get the time motoring as 1 hour. All right, but what is it actually asking? How far did they go by boat? Well, I just found my time by boat. My time motoring was 1 hour. What I need is the total distance that we went. So what I would do is go back up to this part right here. Rate times time. This is how far we went in the boat. And we were going at 15 miles per hour for 1 hour. So that means the total distance is 15 miles that we went by boat. Okay. All right, you guys, I want to try a couple whiteboard problems. So you guys try some of these. All right, since I forgot to record these yesterday, I'm going to add a couple of equal distances and some other types of problems. So on Monday, Voltaire drove to town at 60 miles per hour, and on Tuesday, he drove to town at 40 miles per hour. If the total traveling time for both trips was 15 hours, how far was it to town? So same trip here. On Monday, we're driving to town. Okay, so this is my distance on Monday. And then we're making the same trip on Tuesday. So distance Tuesday. So these are always distances, and I always want a picture. And then we're going to set our distances equal. So distance Monday is equal to the distance Tuesday. And then we're going to replace with rate times time every time. So rate Monday times Monday equals rate Tuesday times Tuesday. So Voltaire drove to town at 60 miles per hour on Monday. So we're going to replace rate Monday with 60. On Tuesday, the rate was 40 miles per hour. So I'm going to plug 40 in for my rate on Tuesday. Total traveling time was 15 hours. This is a side equation we're going to write off to the side. So time on Monday plus all right, so total time, we need to isolate for one of these variables. Does not matter which one. So I'm going to subtract t. So tm equals 15 minus tt. And we're going to plug that in for tm. So I'm going to try to write really small here. 15 minus tt equals. All right. So now we need to distribute this. And we get 900 minus 60 tt equals 40 tt. We're going to add 60 to both sides so we have all of our like terms. So 900 equals 100 tt. And divide both sides by 100. And so our time on Tuesday was 9 hours. And then we go back up and check and see what it's asking for. How far was it to town? They're both the same on either side, so we can actually go back and plug in on either side of the equation. I'd probably go back right here. So the distance is equal to 40 times the time on this side. And so that would be 360 miles. All right, so that's an equal distance. Let's do an unequal distance problem. So Helen has a 4-kilometer head start on Paris. So that means that we've got Paris going the full distance, but Helen got a 4-kilometer head start. So distance, Helen, she went less, so we're actually going to have to add 4 kilometers to her distance to make it equal to the distance that Paris went. So the distance of Paris is equal to the distance of Helen plus the 4 kilometers that she was ahead. And then we always replace with rate times time. And see what we can plug in. How long will it take Paris to catch Helen if Helen travels at 6 kilometers per hour? So here's Helen's rate. Okay. And Paris travels at 8 kilometers per hour, so there's Paris's rate. And then it doesn't say anything about time, but it's talking about catching each other. So we actually start and stop at the same time. So on this type of problem, when someone's catching someone else, the times are always going to be equal. So I'm going to do both as TP. So subtract 6 TP from both sides. And we get 2 TP equals 4. Divide by 2. And so time of Paris is 2 hours. And then, of course, we have to see, what did they ask? How long will it take Paris to catch Helen if Helen travels? So how long is the time? Both times are equal, so it takes 2 hours for Paris to catch up to Helen. All right, and we did a total distance, so I think we're good. Thanks.